So imagine waking up on a Monday, right? And you just decide out of nowhere you are going to completely replace your company's entire global supply chain.
I mean, that sounds completely absurd.
Right. Because you aren't just changing where you buy your materials, you are physically building the new factory.
Right.
You are engineering the custom engine. You are paving the highways the delivery trucks drive on and, writing the code for the autonomous navigation system.
Which is just a massive undertaking.
Oh, and you are going to do all of this in exactly 7 days.
Yeah, it sounds like corporate suicide.
Yeah.
Or, at least a complete logistical impossibility.
It really does. But that is exactly what we are looking at today. So welcome to the deep dive. We have got a massive stack of sources on the table for you today.
We really do.
We've got corporate products blogs, a peer-reviewed paper from the journal Nature, and some pretty intense security briefings from the 2026 RSA conference.
And the wild thing is, all of these sources have one very specific thing in common. They were all published in this single, just hyper-condensed window between March 29th and April 4th, 2026.
Which is, it's definitely going down as a definitive structural inflection point for the tech industry.
Oh, absolutely.
So our mission today is to unpack this specific week. This is the week where Microsoft stopped merely integrating artificial intelligence from their partners, and they started operating their own, basically sovereign, autonomous intelligence empire.
It's a huge pivot.
It is. We are going to look at the actual mechanics of how they are launching in-house models, predicting AI behavior mathematically, and this is crazy, dropping over $16 billion on physical infrastructure.
In 1 week.
In 1 week, we need to figure out what this pivot means for you and for the fundamental nature of how you work. So, okay, let's unpack this. And I think we need to start right at the foundation, the models.
Yeah, that is definitely the necessary starting line. Because to really understand this shift, you have to look at what the Microsoft AI Superintelligence Team, or MAI as they call them, did on April 2nd.
Right.
They released 3 proprietary foundation models onto Microsoft Foundry. You've got MAI Transcribe 1, which is for speech-to-text. You have MAI Voice 1 for speech generation, and then MAI-Image-2 for text-to-image creation.
So for years, Microsoft's whole AI narrative was just, totally tethered to OpenAI.
Right, they were completely reliant.
Yeah, it's like a famous restaurant that always bought its bread from the bakery next door. But now they've just built a state-of-the-art bakery in their own kitchen.
That's a really good way to put it.
But I need to understand the mechanism here, because, are they just spinning up cheap, low-tier models to save on computing costs, or is there actual frontier-level engineering happening?
Well, it is definitely the latter.
Yeah.
But the engineering is hyper-focused on efficiency. So let's look at MAI Transcribe 1.
Okay.
It achieved a 3.8% word error rate on the FLIRWARS benchmark.
Wait, 3.8%?
Yeah. And for the listener, the FLIRWARS benchmark isn't just someone reading a clean script into a nice studio microphone.
Right, it's not a controlled environment.
Exactly. It tests overlapping speech, really heavy background noise, and across 25 different languages. So a 3.8% error rate in those conditions is essentially human parity, if not slightly better.
Okay, so it's super accurate, but transcription has been around for a while. What makes this such a massive disruption?
It's the mechanism of how it utilizes hardware. So it achieves that accuracy while running 2.5 times faster than their previous Azure Fast offering.
Wow.
But here's the kicker. It does that at a 50% lower GPU cost. It literally costs 36 cents an hour to run.
Wait, 36 cents?
Yeah, 36 cents.
Yeah.
And the voice generation model, MAI Voice 1, that one can generate 60 seconds of highly expressive, nuanced audio in under 1 second on a single GPU.
I have to pause you there because whenever I see a company release something that is just drastically cheaper and faster like that,
You get skeptical.
my immediate instinct is that corners were cut. Is this just a race to the bottom for enterprise customers who, care way more about their quarterly cloud bill than the actual quality of the AI?
Honestly, I would normally share that exact skepticism. But the third model they released that week, MAI-Image-2, kind of proves otherwise.
How so?
It debuted in the top 3 on the Arena.ai leaderboard right out of the gate.
Oh, really? Top 3?
Yeah. And this model handles incredibly complex visual layouts. It can render highly specific in-image text without that weird garbled lettering we used to see, a couple of years ago.
I remember the garbled text. It was awful.
Right. So the mechanism here isn't about cutting corners. It's about architectural efficiency.
Yeah.
They have basically figured out how to get frontier-class performance out of a significantly smaller footprint, and they're deliberately pricing it to just completely undercut the market.
Okay, that makes sense. But having a cheap, efficient model is only half the battle. Because if you are, say, a bank or a healthcare provider, you don't just need cheap AI.
No, definitely not.
You need AI that isn't going to hallucinate and, completely ruin your business. And that actually brings us to the piece of research from this stack of sources that just absolutely fascinated me.
The Nature paper.
Yes. On March 31st, Microsoft Research published a paper in Nature about this framework called ADeLe.
Yeah, and what's fascinating here is that ADeLe effectively ends the era of the manual vibe check.
Right. Because for the longest time, testing an AI felt like, I don't know, throwing spaghetti at a wall.
It really did.
You ask it 100 questions, it gets most of them right, and you just kind of cross your fingers and hope it doesn't invent a fake legal precedent when a real customer talks to it.
It was incredibly unscientific, just trial and error.
Exactly.
But ADeLe, which by the way stands for AI Evaluation with Demand Levels, it changes the underlying mechanism of how we evaluate models entirely.
Break that down for me.
Well, it scores both the tasks and the models across 18 distinct cognitive abilities.
Like what?
Things like spatial reasoning, attention span, and domain-specific knowledge.
Okay, walk me through how that actually works in practice. Because how do you mathematically map a task to an AI?
Think of it like a highly advanced athletic combine.
Okay.
If you want to know if an athlete will be good at a brand new sport they've never played, you don't just ask them, hey, are you fit?
Right, that wouldn't tell you much.
Exactly. You measure their vertical leap, their fast-twitch muscle response, their cardiovascular endurance. You create a profile. And ADeLe does this exact thing for AI.
Oh, wow.
It maps the specific demand profile of a task. So, say, analyzing a 50-page financial disclosure against the ability profile of a specific model.
So it's comparing those two profiles.
Right. By comparing those vector profiles, ADeLe can mathematically predict if a model will succeed on a completely unseen task with roughly 88% accuracy.
88%. That is a fundamental paradigm shift. I mean, you aren't just testing the AI after the fact. You are forecasting its failure modes before it ever even hits production.
Exactly. And if we connect this to the bigger picture, think about this. If you can predict a model's success with 88% accuracy using ADeLe, and you can generate responses incredibly cheaply using those new MAI models.
Right.
What is the logical next step? You don't just have humans typing prompts into a chat box anymore. You let the models operate autonomously.
Which is exactly what happened on March 30th. Because Microsoft moved way beyond this single prompt chatbot, and they announced Copilot Cowork in their Frontier program.
Which is a huge deal.
It is. This is a fully autonomous agent.
Yeah.
You give it a high-level goal, and it executes multi-step workflows across your email, your documents, the web, completely on its own.
It's running in the background.
Exactly. But the part of this announcement that I really want to dig into is the multi-model capabilities they added to the researcher agent, because they introduced these features called Critique and Model Counsel.
Yeah, and this is a brilliant structural play on Microsoft's part.
How so?
Well, they're taking OpenAI's GPT models, which, are historically fantastic at creative generation and synthesis.
Right.
And they are essentially forcing them to collaborate with Anthropic's Claude models, which are really renowned for their analytical rigor and extreme caution.
Okay, but I am genuinely struggling to see the efficiency here. I mean, if I pit Claude and GPT against each other to argue over a research paper, aren't I just creating a sluggish AI bureaucracy?
That's a fair point.
Like, I'm doubling my compute costs and I'm slowing down the response time just to have two robots bicker with each other?
What? If you are just asking it to write a polite email to your team, then yes, it's a massive waste of resources.
Right.
But we are talking about writing emails here. We are talking about deep, multi-domain enterprise research. So let's look at the DIACO benchmark.
Okay, what does that measure?
It measures a model's ability to handle complex, multi-step logical deduction. By combining GPT and Claude, the researcher agent's accuracy jumped by 13.88% on that benchmark.
Wait, nearly 14%. On a benchmark like DIACO, that is practically a generational leap.
It is. And the mechanism of the model counsel feature is really what makes it so valuable. Think of it like a courtroom.
Okay, I like that.
GPT is your brilliant, but maybe occasionally overzealous prosecuting attorney. It drafts this highly compelling argument.
And Claude?
Claude is the skeptical defense attorney. It's just poking holes in the logic and pointing out missing citations.
Yeah.
But here's the genius part. Model Council doesn't just quietly blend their answers together.
What does it do?
It surfaces the actual transcript of their disagreement to you.
Yeah.
It presents the divergence so that you, the human judge, can make an informed decision.
Oh, that's brilliant.
Right. It directly attacks the hallucination problem by basically institutionalizing adversarial review.
I really love that courtroom analogy because it frames the AI not as this, magical oracle that just hands you the right answer, but as a team of analysts showing their work.
Exactly.
And importantly, Microsoft didn't just lock this multi-agent architecture inside their own apps, because on April 2nd and 3rd, they released the Agent Framework version 1.0.
Unifying semantic kernel and autogen.
Right, alongside a public preview of the GitHub Copilot SDK.
Yeah, they are essentially taking the exact same runtime environment that powers their own cloud agents and handing it to every developer on Earth across 5 different programming languages.
And the feature in this SDK that really caught my eye is the bring your own key mode.
Oh yeah, that's big.
Because a developer can embed this powerful multi-agent Copilot runtime directly into their own custom app, and the end user using that app doesn't even need a Microsoft Copilot subscription.
Which is wild.
The developer just plugs in their own API key for Anthropic or OpenAI or, the new MAI models. It feels very anti-monopoly.
Well, it's highly strategic.
You think so?
Oh, absolutely. By allowing bring your own key, Microsoft removes the massive licensing friction that usually stops developers from adopting a new framework.
Ah, I see.
They are untethering the developer from the Microsoft consumer subscription, sure, but they are firmly locking that developer into the Microsoft infrastructure stack.
Right. And that leads us perfectly into the physical reality of all these announcements. Because software does not exist in a vacuum.
No, it definitely requires hardware.
Exactly. If you empower millions of developers to build these courtroom-style model councils, where multiple AIs are constantly analyzing data and arguing with each other in the background,
You are going to need a lot of power.
you are going to completely melt the cloud infrastructure of 2024.
The physical compute requirements for agentic AI are just staggering.
Yeah.
And that is exactly why between March 31st and April 3rd, Microsoft initiated an infrastructure blitz in Asia that is, honestly, almost hard to comprehend.
Yeah, let's talk about that.
We are talking about $16.5 billion committed in a single week.
It's unbelievable. Let's break those numbers down. $10 billion in Japan, $5.5 billion in Singapore, over $1 billion in Thailand.
It's massive.
And this isn't just about throwing some new server racks into an existing building to make search queries load faster. The overarching theme across all these sources is this concept of sovereign AI. Help us understand the mechanics of sovereign AI. Like, why does Japan care where the physical server actually lives?
Well, it comes down to data residency and geopolitical security.
Oh.
Nations have really woken up to the fact that AI compute is a critical national asset. It's on par with their electrical grid or their water supply.
Wow, that's a serious comparison.
It is, but it's accurate. The Japanese government wants absolute certainty that the proprietary data powering their economy, their financial models, their healthcare records, their defense logistics, that it never physically leaves their borders.
So they don't want it traveling across an underwater fiber optic cable to some server in California.
Exactly. So sovereign AI literally means the physical GPUs in the data centers are locked down on domestic soil, subject only to domestic laws.
Okay, that makes total sense.
And Microsoft is facilitating this by partnering with local domestic powerhouses like SoftBank in Japan to build this localized capacity.
Right, but physical infrastructure is completely useless without the human capital to actually run it.
Oh, 100%.
So alongside the data centers, Microsoft is training 1 million engineers in Japan. And in Singapore, they're providing free Copilot access to over 200,000 university and tertiary students.
Yeah, they aren't just building the factory, they're proactively training the entire next generation of the local workforce to be natively fluent in the Microsoft ecosystem.
Which is just a brilliant long-term play. And they are taking that factory to the absolute edge of the physical world, too. Because on March 30th, Azure announced a partnership with a company called Armada to deploy Azure Local on Galleon modular data centers.
Yeah, this was definitely the most sci-fi visual of the entire week for me.
Tell me how this actually works.
Well, imagine a highly ruggedized, military-grade shipping container.
Okay, I'm picturing it.
You drop this container via helicopter into the middle of a remote mining operation in the Australian outback, or maybe onto a forward-deployed naval base.
Wow.
And it has zero connection to the public internet. It is entirely air-gapped.
No internet at all.
None. Yet inside that container, it is running a localized, state-of-the-art AI brain.
So, using something like the Foundry local capability, a team of geologists at a remote drilling site can run massive, complex data analysis models entirely offline.
Precisely. It allows bandwidth-constrained or highly classified industries to utilize the exact same AI tools as a tech company in Silicon Valley.
That's incredible.
And they could do it without sacrificing an ounce of security or relying on some fragile satellite internet connection.
Yeah.
It extends the concept of the sovereign cloud to places where fiber optic cables literally cannot reach.
Taking AI entirely offline for defense and critical infrastructure is brilliant, but, it naturally begs a much darker question.
It usually does.
What happens when this technology is used offensively? Because Microsoft is building these incredible agentic tools, but threat actors are scaling their capabilities at the exact same time.
Yeah, this is the most critical piece of the puzzle, and it was addressed head-on at the RSA conference on April 2nd.
Right, the security report.
Yes. Microsoft Security published a report detailing how AI has fully infiltrated the cyber-attack lifecycle.
Let's talk about the phishing data from that report, because the mechanism behind it is terrifying.
It really is.
We all know what traditional phishing looks like, right? It's an email from a strange address with bad grammar, urgently asking you to reset your password.
Very easy to spot.
Exactly. And the success rate on those old campaigns was around 12%. But at RSA, Microsoft reported that AI-enabled phishing campaigns are now achieving a 54% click-through rate.
Which is it's a 450% increase in effectiveness.
54%. More than half the people are clicking.
Yeah, and to understand why it's so successful, you have to look at how the AI is actually executing the attack.
How does it work?
The threat actor doesn't just write a generic email anymore. They use an AI agent to scrape your company's entire public footprint.
Okay.
The AI figures out the exact corporate hierarchy. It might ingest a cache of leaked emails to learn exactly how your CFO speaks, their specific tone, their inside jokes, the exact way they sign off an email.
Oh, wow. So when the target receives the email authorizing an urgent wire transfer, it doesn't look like a scam at all.
Not at all.
It looks, sounds, and feels exactly like their actual boss.
Exactly. The report highlighted a single phishing-as-a-service platform called Tycoon 2FA that compromised nearly 100,000 organizations.
100,000.
Yes. AI has definitively shifted here. It is no longer just a defensive tool used by cybersecurity teams to spot anomalies. It is now the primary automated cyber attack surface that enterprises have to defend against.
And this brings us to a massive collision course, because earlier we talked about empowering developers to build autonomous agents that can navigate your corporate network, read your emails, and execute workflows.
Right.
If the external threat landscape is this sophisticated, how can any chief information security officer safely authorize an autonomous AI to run loose inside their company? I mean, what if a phishing attack tricks the AI agent instead of the human?
Well, that exact scenario where a prompt injection tricks an agent into mass deleting files or exfiltrating data is exactly what Microsoft targeted with their final major release of the week.
The governance tools.
Yes. Between March 31st and April 2nd, they released the Agent Governance Toolkit as an open-source project alongside an adaptive governance framework from the Power Platform team.
I look at this toolkit like putting high-performance carbon ceramic brakes on a hypercar.
Oh, that's a great analogy.
Right. You don't spend thousands of dollars on a braking system because you want to drive slower. You install them so you have the psychological confidence to drive 200 miles per hour, knowing you can stop on a dime if you need to.
That analogy is spot on. Because if an enterprise knows they have absolute granular control over an agent, they will deploy it much faster.
Exactly.
And the mechanics of these digital brakes are incredible. The toolkit specifically addresses all 10 of the OWASP agentic AI risks.
Which, for context, OWASP is a globally recognized standard for software security.
Right. And agentic risks refer specifically to vulnerabilities, where an AI takes independent, harmful action.
And how fast can this toolkit actually stop a rogue agent?
It enforces policies with sub-millisecond latency.
Wait, sub-millisecond?
Yes. We are talking less than 0.1 milliseconds at the 99th percentile.
That is basically instantaneous.
It really is. It sits right at the runtime level. Before the AI agent can even execute an API call to, say, delete a database, the toolkit intercepts the request, evaluates it against the corporate policy, and blocks it instantly.
Wow.
This level of microscopic control is going to be absolutely vital as companies scramble to prepare for the heavy enforcement of the EU AI Act.
And it solves the human problem, too, because the Power Platform team's adaptive governance framework is a massive departure from the old way of doing IT security.
Oh, definitely.
In the past, companies would just issue this massive static binder of security policies that basically banned everything. And what happens? Employees just use shadow IT.
They always do?
They use unapproved AI tools on their personal phones just to get their work done.
Which is infinitely more dangerous.
Yes, exactly. But the adaptive framework solves this by establishing dynamic graduated risk zones.
Right.
It mathematically separates a low-risk action, like an agent summarizing a public PDF, from a high-risk action, like an agent attempting to access the company's proprietary financial database.
It enforces hygiene at the data access layer.
Yes, allowing employees to innovate freely in the safe zones while applying maximum friction in the restricted zones.
So let's step back for a second and look at the absolute sheer velocity of what we've covered today.
It's a lot.
Over the course of just 7 days, from March 29 to April 4, 2026, we watched a company rewire its entire ecosystem.
Yeah.
They built the MAI foundation models, proving they can engineer ultra-efficient intelligence in-house. They published the ADeLe framework, allowing them to mathematically forecast how that intelligence will perform before it's ever deployed.
And then they unleash that intelligence as autonomous multi-model agents in Microsoft 365, literally creating digital courtrooms where GPT and Claude argue to find the most accurate answers.
Right. They backed all of that software up by committing $16.5 billion to sovereign physical infrastructure across Asia, securing the chips and the talent to power this new world.
And finally, they open source the sub-millisecond digital brakes, the Agent Governance Toolkit, to ensure these systems don't become weapons in the hands of bad actors.
It is an end-to-end replacement of the technology supply chain, the engine, the evaluation tools, the infrastructure, and the governance.
It is a phenomenal feat of engineering. But, it leaves you, the listener, with a rather profound question to consider regarding your own role in this ecosystem.
Yeah, really does.
What's the lingering thought here?
Look at the trajectory of this single week. We've seen that AI models are now evaluating other AI models through the critique and model counsel features.
Right.
We've seen that they can predict their own operational success using the ADeLe framework, and we've seen that they can govern their own security behaviors at the runtime level through the Agent Governance Toolkit. So as these systems become entirely self-regulating, evaluating their own logic, testing their own capabilities, and checking their own blind spots, where exactly does your human intuition fit into the future of your daily work?
That is the multi-trillion-dollar question right there. We're moving from a world where we operated the machines to a world where we manage the machines, and increasingly a world where the machines manage themselves.
The supply chain has been rebuilt.
It has, and it's moving faster than we can fully comprehend.
Thank you so much for joining us on this deep dive. Keep questioning the evolving tech landscape around you, and we'll see you next time.